Okay, so we can start. And like I mentioned, we are going to discuss debugging as well as debugging in MATLAB. So I'm going to start the discussion just like we've done for all of these talks. What do you think are some good steps / tips / what do you do for when you're trying to debug something? Okay, so you need to identify there is a bug. Okay. What else?
Yeah, like 3,000.
Okay, so you want to print out relevant information, right? How do I figure out what this relevant information is? So check error, like if there is an error. Otherwise, if there's no error and it's just a bug that you're noticed, so check values / code near where you think the bug is, right? So what else can we do? After we've printed out values, what would we do? So I would change it based on what I figured out, what is happening, right? So let's say that we're going to then edit the code to C, not to C. Edit the code to attempt to fix the bug, right? And when I'm editing code and I'm trying to do debugging, should I edit a whole bunch of code or small steps, right? And then once we've edited it, what are we gonna do? Rerun, see if what's expected is output, right? And then probably iterate until the bug is found, right? We're gonna keep iterating until the bug is found and fixed. And then after we think we've fixed the bug, what is something that we talked about before that we might want to do? Run all tests. Okay. And maybe you can write new tests to help debug. Right? We talked about test-driven development. So if you have found a bug that your tests are not covering, part of your debugging process might be writing a new test first. Okay. So this is good, but I'm going to go through some more formal steps. And again, slides that I have from a different class I was teaching. So let's look at those slides. So we know bugs are prevalent all over, even in deployed software. We have bugs, right? It's just a matter of what is necessary to fix in terms of deployed code, right? And do you have the resources? Is it something that is really affecting your overall program? Or is it a really small edge case that many and most users don't encounter, so it's low priority? So part of the debugging process is having this kind of priority list of reported bugs, right? So this process of debugging is detecting, diagnosing, and fixing problems in software. And one thing that we should always keep in mind is the average time spent debugging compared to total development time is the majority of development time. Right, you get your first initial implementation, say for like your programming assignment, maybe it takes 2-3 hours. You can probably expect to spend at least 5 hours fixing all of the bugs in your first initial implementation. And the more complex your projects become, the more time you're spending debugging. Have we found that to be true? Right. And then one thing that you can keep in mind when you're coding is knowing how to debug will reduce the time to fix these inevitable bugs. So you can try and learn to be more efficient with debugging. And then this is just story of the first computer bug. And again, because of this, the more efficient you are debugging, the more efficient you will be at coding. So bad debugging practices, just making random changes and hoping that it would work. And this doesn't necessarily have to be completely random. It can be that you saw this bug and then you thought about it for like a minute and then you thought of a change and you're just trying that immediately rather than doing the steps that we just talked about with thinking through the code, looking at the error messages, whatever it is to kind of devise a plan before you start making changes. The other thing is just Googling things and trying to apply them and just seeing if it fixes things. So this could be like you have an error and you just copy paste the error code in Google and then you try and apply the change. This can be very helpful in some situations, but most of the time it's for situations like you're new to a new programming language and it's some syntax error, But even if that is the case, you should not just be blindly copying and pasting these fixes. You should kind of try and understand what the change is and apply it based on that understanding. And maybe part of that process is looking through multiple different sources and not just, I'm going to try this one first, then the next link is this one, I'm going to try that one next, right? And then another bad practice is if you broke something else, just reverting and starting again. So some kind of attitudes towards debugging. It's bad to have this attitude of this is too hard for me to understand. And it's frustrating. You want to kind of go into it with, let me think of it step by step, make sure I understand every single step that is involved in this process that I'm trying to debug, and then slowly figure out the problem. Don't be too overwhelmed if the maybe code base that you're debugging or whatever is a little bit large and you're not sure where to start. And these are just some tips to keep this attitude. So just remember that bugs happen for a logical reason. Right? Just because you kind of look through the code and it's frustrating you that you can't find it yet, there is a reason that these bugs are happening. It does exist. It's just a matter of time before you find it. Okay? And you can learn from every single bug that you fix. Right? Most probably you're fixing bug in your own code. Right? So after you fixed one bug in your code, now you know for the future, okay, I won't make that mistake. And the other thing is never expecting your code to work the very first time. Right? It goes back to average time spent debugging is more than half the time total. And like we talked about, you guys said, change one thing at a time. Do very small steps. And something that could be helpful, especially using some new API or new code base, new program, is reading documentation. And another thing is talking to other people. So this could be paired programming. It could be talking to colleagues. Or it could be, I've been working on this bug for an hour. I need like a fresh set of eyes to look at it with me. Because maybe it's something simple that I'm just overlooking. Because I've been writing this code and trying to debug this code for the last few hours, and my brain is just not up to the task at this moment. So just some terminology with debugging. So symptom is the faulty program behavior that you are seeing. So it could be like crashing from a seg fault, producing a wrong answer for your test case. It could be an infinite loop, right? The symptom is the problem that arises. The bug is the flaw in the program. So the resulting output is not the bug. The bug is the program itself, right? And one bug can cause 0 or more symptoms. And then we have latent bugs that kind of show up much later in the process. Maybe it's an edge case that you didn't write a test for, or you didn't know that existed until you encountered it. And then debugging is using those symptoms and other information to find and fix those bugs. Okay. So a failure-inducing input is an input into the program that causes the bug to execute and for a symptom to appear. So like if your program does not handle an empty list and inputting an empty list into your program results in an error every single time, that's your failure-inducing inputs. Okay. And one thing that we like when we're debugging is a deterministic platform. So something that will have the ability to reliably reproduce the bug from the failure-inducing input. So this is not usually a problem with simple programs that you guys are mostly going to be making in like classes. But as you get into more complex programs that are non-deterministic, maybe they have random functions in them, it can be good to have some kind of setting or platform in your code base that will eliminate all of that non-deterministic code and maybe use seeds for the randoms just so that you can have this consistent reproduction of bugs. All right, so we talked about a few steps, but here are some more formal steps. So the first step is to verify the bug and then determine what is the correct behavior that should happen rather than the symptom that is occurring. So this is basically just ensure that there is a bug and understand what should have been the outputs. Then the second step is to stabilize, isolate, and minimize. So you're going to try and reproduce the bug deterministically by isolating some failure-inducing input. And after you have that failure-inducing inputs, you're going to try and make it as small as possible. So is it really because I have this very long list, or is my smallest failure-inducing inputs a list with just a negative number, and my program is just not handling the negative number? So it's trying to find the smallest failure-inducing inputs as possible. And step 3 is to kind of estimate this probability distribution of the bug. It's kind of what we talked about, kind of thinking about your program. Where is the most likely location of this bug in my code, given the symptom? And then once you have that, you can devise and run an experiment. So this is where we're talking about adding those print statements, using that failure-inducing input, seeing all of the intermediate values that lead up to that symptom. And that will help you isolate where in your code the bug occurs. Okay. And then step 5 is to iterate until the bug is found. And once you've found the bug, try and fix it, again, with doing the smallest of changes. And then once you fix the bug and you run all your tests, you're going to undo all of that, those print statements and things that you've added to help you while you're debugging. And then one thing that you might want to do is you fixed that one symptom from that one bug, or maybe multiple symptoms from that bug. Are there any other failures in the code that are related to that bug? And then here are some things that you can try if you get stuck. The first thing is reducing the size of the failure-inducing inputs. So trying to find the smallest thing that you can look at to change. Adding more kind of breakpoints, debug print statements, And then another thing you can do is find a tool that can help you extract more information from your code. So many different coding platforms and programming languages have debugging tools. So you can utilize those. And I will show you the documentation for the debugging tools in MATLAB at the end of the lecture. Another thing is taking a step back and ask questions about any assumptions you have. That's similar to talking to someone new to discuss the problem. One thing that it could be helpful to you, it could not be helpful. It depends on you. But looking at the code line by line and trying to understand each step very slowly can help. But it might be more helpful after you've taken a break. Okay. Another thing is just changing other things. Like restarting your computer, using a different machine, trying to reproduce the bug. Again, deterministically. Right? Right, so this just goes back to how we talked about a bug can have multiple symptoms. So this is one bug. And we have two different failure-inducing inputs because we have these two symptoms from the same bug. So this bug on the bottom occurs because we end up out of bounds for arrays that are odd in their size. So any array that's 5, 3, 1 will end up with this index out of bounds because we're looping through I through the length of the array, but we have I plus 1 here. And we also have this bug where we're getting an unexpected output for our inputs. Right? So this is just reminding you, like you can fix one bug, but it could be related to multiple different symptoms. And again, this is the same thing, except now we have two different bugs causing the same symptom. Okay, so you might fix your program in one place, but you might have the same symptom coming from a different place in your program. And then this is debugging in Visual Studio Code. This is the IDE that we were using for this class, but here we're using MATLAB, right? So I'll show you MATLAB. So any questions on this debugging process? We learned something new from this, hopefully, right? Help us with the debugging process. Right, because it all, again, goes back to this first slide and this statement. The more efficient you are at debugging, the more efficient you will be at coding. Right? So I know we all don't really like debugging, right? But it is an important skill to have and to be able to go through these steps efficiently and fast. All right, so let's look at debugging tools in MATLAB. So if you just Google MATLAB debugging, it has this whole document to run you through these different tools in MATLAB to help you with debugging. Like you can make these breakpoints where it will run up to this line in the code. And other things that you can do is they have this step to go line by line. Right? And in MATLAB, you don't really need to add all of these print statements because you have these tools. And on the side of MATLAB, you have that variable pane, right? You can see everything that is a local variable in your code. So having these breakpoints, using the step function, and then looking at the variable pane can be very helpful when you're debugging in MATLAB. And they have other tips here, and I'll let you guys look through this on your own. But if you're stuck and you're debugging something, it could be helpful to look through here. Okay. And these are kind of the key functions that you want to be able to learn and do. Okay. So that is debugging. Do we have any questions on debugging? Okay. So I'll stop this, stop sharing.